All right, hi everyone. This is Vishal Sharma with the Carry Ethernet Group back with another edition of CE Live. And today I'm extremely delighted to have two fantastic guests with us who are also very active group members. One is Marcus Friman from VP at Netrounds, and those who've been following the group, you've followed the discussions on L2CP that we've been having lately. And the other is Khurram Shahzad, who's been a member of the group for a few years now. And you've seen some of Khurram's postings on SDN strategy and technology, and I've invited Khurram over to discuss that. So why don't you guys say hello to the group, and then we'll get started here.
Hello, everyone.
Hi, everybody. It's Khurram here.
All right, great. So what I'd like to do, typically this is give people a quick rundown of the kind of things we're going to cover. So let me do a quick screen share and show people a table of contents. So let's see what happened here. Give me one sec. That's always the interesting part of being live, but we should be able to. Okay, there you go. All right, so this is the CE Live, and I had already announced some of the things we are going to cover. So in the first 10 minutes or so, I quickly want to cover 3 or 4 important developments in the group, specifically talking about data center design and what Facebook is doing in that area. Talk a little bit about mobile video advertising. It's related to kind of layer 7 technologies and what's really going on there, and it's more about business and strategy. But I think that's an interesting thing for us to be talking about. And then we'll talk a little bit about Arista's earnings and what that really means for data center growth. How that relates to the marketplace. I think that's an important dynamic for us to track. And then finally, we'll talk a little bit about what's going on with 802.11 AC and some things called the radio cloud from Nokia. And then this is all to be covered in the first 10 to 15 minutes. And then we'll spend the bulk of our time doing discussions on 2 topics. One is Khurram has written a lot about the technology options for SDN and NFV, and also some non-technology considerations that providers must keep in mind, and we'll have him sort of walk us through those ideas and some of the thought process behind it. And then, of course, very interesting L2CP tunneling discussions that Marcus initiated. There's been a lot of activity on the group for that, so we'll talk about that. And of course, let me also quickly show you where the discussion is. Some of you who've been following it know the discussion on the group, but the right place to ask questions is really the announcement of the CE Live on the group. And let me just do that. This is actually Marcus's discussion I have, but let me go back. If you go to the Manager's Choice discussions, the CE Live discussion is like number 1 or number 2. So let me quickly do that. And you can post your questions there, and we'll just be tracking that as we keep going. So let me show you where that is. Oops, I think I went the wrong direction. So this is the discussion that relates specifically to the CE Live, and as a way of getting everything in one place, I think this is where you should post your questions. And we'll be looking at it periodically. Oh, wait a minute, sorry. That's the previous one. My apologies. Actually, I believe I had changed this, but I haven't. So let me show you where that discussion is. It's a little bit down here. We have so much activity in the group that things sometimes tend to get buried. There you go. So that's the discussion that you want to focus on. It's in the main window. If you scroll down a few of the topmost discussions, you'll come to this. So this is what it looks like, and this is where we want to be to ask our questions. And you can start posting your questions here periodically. We'll check that. So that's sort of the logistics. Now let me dive right in to the first topic of the day, which is, there was an announcement by Facebook about a 6-pack switch. And let's quickly talk about the implications of that. So what the 6-pack is an open hardware modular switch, and it's really a 2-stage non-blocking full mesh switch. Full mesh meaning that every input port can talk directly to the output port. And what Facebook has done in this is that they're using their wedge top-of-rack switch architecture and the components that they announced about a year ago as a building block for this modular switch. And the switch has a capacity of up to 640 gigabits times 2, so about 1.28 terabits per second. And you can have it, depending on the role it's playing, it can have all of that facing the front end if it's an aggregating device. And if it's connecting higher up, in the hierarchy, then it can have 640 gigs in front and 640 gigs at back. And let me quickly tell you what is interesting about the way Facebook has architected Facebook that actually shows that architecture. So let's quickly do a screen share and look at that and what's special about this. So before I talk about the architecture, a little bit on the switch. So this switch that they've announced, it's called 6-pack, and it's an example of hybrid SDN, which basically means that every switching element, every little switch, has a full local control plane, but the entire set of switches is controlled by a centralized controller. And the advantage for this is that it makes the switch extremely stable because you have a local control plane and a central controller. You can have very high availability. And that kind of aligns with Facebook's philosophy. I mean, for about a couple of years now, they have been sort of saying that the scale and pace of operation that they work at is so fast and it's so gigantic that they've run out of options from the regular sort of switch provider. So they went off and said, okay, we got to start building modular products, what they call disaggregated systems, which give us flexibility, scalability, and efficiency. And so they started with their wedge top-of-the-rack switch, and a completely different, and of course a Linux-based operating system called FBOSS for that switch. And they also built a new data center fabric. And let's look at that, what that data center fabric looks like. So the key aspect to be focused on is that instead of using the traditional hierarchical data center hierarchy we all know of, access, aggregation, core switching, they built server pods, which was essentially a new unit of the network for Facebook. And a server pod actually consisted of 48 top-of-rack switches, which could communicate with 4 fabric switches. And this was one unit as far as Facebook was concerned. And then they built an entire modular network architecture, which is shown in this diagram here, using these server pods. And the way they did that is they arranged server pods in spine planes, which you see as planes 1, 2, 3, 4 here. And they arranged them also in terms of vertical rack switches that could allow these planes to communicate. And then to allow extra plane communication, you had these edge switches that could allow communication outside, up and down the chain. So as you can see, they've changed the 3-level hierarchy we're very used to seeing in data centers to this spine and server pod architecture, which uses as the building block the server pod that they define. And the server pod in turn uses the wedge top-of-the-rack switch that they define. And so the 6-pack is really playing the role of these fabric switches, which they had not yet defined. So they essentially built their own fabric switches using architectures and components from wedge. And so the simplified data center architecture really begins to look like this. And what it allows now is concentrations of these server pods in different planes, which you can connect with very high capacity fiber optic equipment. And so that's something you need to understand. And the final point is they're going to bring this into the Open Compute project pretty soon later this year. And the goal is that they want to open up networking design, which is of course something they've done. And coincidentally, last December, Juniper announced that they are going to build an Open Compute hardware compatible switch, which they call the OCX 1100. So there are other vendors that are kind of taking a cue from Facebook and moving on with that. All right, the next topic I want to quickly talk about is the growth of mobile video advertising. And for that, what I'm going to do is I'm going to go old school and share with you a little mind map, hand-drawn mind map that I created. So let me just do that. Give me 1 sec here. Just a sec. The screen share is always interesting because sometimes it doesn't show you all of the windows that are open. In fact, it's not showing me my mind map right now. Okay, so let's not worry about it. I'll make the mind map available when I give you the link to the to this mind map that I always create for every talk. But there are 4 factors that are actually affecting mobile video advertising. And just to give you a data point, it's doubled in 2014 and is the fastest growing advertising category. And one might ask, okay, what is it that's causing that to happen? And there are really 5 factors, actually 6, that are responsible for that. One is that mobile video advertising really has an impact on the users, because what the business model that's being used is to create reward ads, which basically reward a user for some kind of participation in a game, participation in some kind of a sequence of activities, and as a reward you can get sponsored to the next level, or you can get some in quotes game bucks that you can then use as currency for playing more games. And it's been discovered that videos have been the most popular in this reward ads category. So that's the first thing that has happened. The second is that the experience of video ads has been found to be very positive, because what developers have been able to do using new techniques is integrate apps, integrate these video ads into the apps. So now you're viewing ads in context, in the context of a game you just did, in the context of a video you just watched, and so you're a highly engaged user who's ready to engage with that content. And so the developer experience allows you to integrate this into apps. That's the other thing that's driving a great amount of interest in using video ads and as a vehicle for advertising. The other is that the dollars from ad spending on TV are actually moving to the mobile, and it's predicted by some studies that by 2018 the digital video ad spend is actually is going to exceed that of television for the first time. I mean, we've already exceeded the time that people are spending on their mobile phones has already exceeded the time that they're spending watching TV today. So we've already crossed that barrier. Now we're also going to cross the ad spending barrier, which obviously puts a lot of fuel into this fire. Finally, people are finding that the video trailers are a great way to drive apps and downloads of applications and purchase of applications. So imagine that you were playing a game and you're shown some kind of a web page. Well, that's a lot less interesting than actually having a little trailer video which you can see what the game's actually going to look like. And if you're an engaged game player, you're much more likely to download that, and that's beginning to happen, and driving a video ad explosion. And finally, as you might imagine, and that's of interest to us as comm technologists, is communication technology. 4G LTE rollouts. Today we have 300 million subscribers in over 350 networks in 111 countries worldwide, and this is only going to grow. And this is absolutely crucial for mobile video ads, because if you can't watch the video ad, you can't watch your mobile video, then everything just comes to a standstill. So these factors are propagating a tremendous growth, which is projected to continue in 2015 and beyond. And that's a category. Watch out! You might want to look out for Patrick Lopez's, who's one of the mobile video experts who keeps posting on our group. He's a good friend and colleague, and some of his writing is interesting in that regard. And the last part is that you can do a much more effective ad targeting for the reasons I already mentioned earlier. That because you have users engaged, because you can do video ads, because you can do an in-context display of ads, you have much more effective targeted advertising ability, and that is putting a lot of money behind mobile video ads, and therefore a growth in the ads themselves. So that's the second topic I quickly wanted to walk you through, and I think that's an important one to note. And now let's talk a little bit about what's going on with Arista networks. So everybody knows Arista now, a big player in the data center Ethernet switch space. If you followed the sort of buzz, in December, Cisco sued Arista for copyright and some patent violations, and that led to a drop in Arista stock by about 12%, which hasn't really recovered until they announced very good quarterly results just a few days back. They had $170 million, $3 million quarter, net income of $31 million. They're up 50% year over year. So, and their two big customers are Microsoft, which comprise almost 15%, Facebook. So what does this tell us about trends in data center networking? What it tells us is that among other players, they are supplying to the mega data center providers. And if you have been following the news, I mean, the mega data center providers have been building a lot of these big data centers, and Arista is becoming a big player. They're slated to reach $1 billion in revenue pretty soon. But the thing to keep in mind is that if you look at Arista's stock price, it's almost 40 times their earnings per share. If you look at Cisco's stock price, it's a more earthly 14 times earnings per share. So there's a lot of optimism still built into what Arista can, will, or should do. And if the parallel that I'd like to draw is the parallel where Juniper and Cisco were about 16 years back in the late 1990s. when Juniper was about the same level. They had about $800 million in revenue, and they were going to come kill Cisco. That was the expectation. Well, it didn't quite pan out that way, although they did become a big player in the whole thing. So you need to worry about watching Arista, if you're an Arista watcher, both from a technology and sort of an industry perspective, as to how they're going to evolve, and can they avoid the pitfalls that Juniper fell into, and how are they going to actually sort of battle it out with Cisco. The good part with Arista is that they are tackling a much larger data center market, an Ethernet switching market, which is much larger than sort of the core carrier market that Juniper was targeting those days. So that's a bigger market to target, a lot of diversity in the market. You can also have enterprise customers, which was not Juniper's forte. So we have those things going for Arista. And then just to close up, the last point I wanted to mention in this quick update is, again, bringing focus back to sort of mobile networks. And in that, there were some postings on the group regarding Wi-Fi and 802.11 AC, which fundamentally is the next generation of 802.11n. And what's making it important is that there is a battle. It's going to scale up the rates to supposedly 1 gigabit per second and beyond. And so there is a battle in the industry among two consortia, one led by Cisco, Freescale, Xilinx, which is called the NBASE-T Alliance, and the other led by Aruba, Avaya, and Broadcom, which is called the MGBASE-T Alliance, which are fighting about what the interface bandwidth on the back-end access points and switches should be to supposedly take this high bandwidth, 802.11 AC traffic. But it's, if you look at the analysts and if you look at the technology analysis, what people have said is that you're probably not going to reach these gigabit levels in practical use. So maybe you don't have that much to worry about the backend right now. Nonetheless, the battle lines are being drawn, and the proposal is that 10 gig is too expensive. You have to change the entire cabling in the enterprise environment. You can't use Cat6 anymore, and that's too expensive. So you don't really want to do that. So the proposal from these two consortia is to use either 2.5 gig or 5 gig interfaces, and that's where the battle is right now. And that's going to be played out, in the next couple of years. But the important point to note with 802.1 AC, and I've given links in the mind map that you'll see, is that it's not all hunky-dory. 802.1 AC uses 160 megahertz wide channels, which basically reduces the number of channels that you can have from like 48 in normal Wi-Fi to something like only 4 or 5. And if you make 160 gig channels, you might have only 1 or 2 effective channels. So you kind of come back to avoiding the interference problem, which is pretty critical in Wi-Fi for throughput purposes. So that is another factor that could limit, how much bandwidth you can really get in an 802.1 AC network. So with that, I kind of have covered the 3 or 4 important topics that I wanted to cover. And let me now bring in both Marcus and Khurram. So Khurram, maybe we can talk about your analysis first. You had analyzed SDN NFV from a technology perspective, and then you wrote about sort of the non-technology perspectives. So can you take over the thing, and I'll hand over the show to you, and kind of discuss with us your analysis and some of the key points that you presented. Hello. Hi, Khurram, are you there? Okay, I'm not sure what happened to Khurram. I'm not getting a signal. So, Marcus, maybe we can start with you first, and we'll get back Khurram when I have him on again. Let me figure out what happened to him. So, why don't we talk about the L2CP problem? So, you had posed the question, and you can do a screen share actually and show whatever you'd like, starting from the discussion. And what should be done with L2CP tunneling, and I'll let you take over and walk us through the problem.
Okay, thank you very much for bringing this quite interesting detail of layer 2 control protocol handling into this program. And yeah, my name is Marcus Friman. I'm from Netrounds. So we cover quite a wide scope here at this hour, everything from mobile advertising to layer 2 control protocol, which is really a detail, but maybe a quite important detail. So I really, since, as you said, I posted this as a question and as a discussion to the group about a week ago. So I will try to explain the background and what the question actually was. And of course, I hope for for some input also from the listeners here, and maybe some questions or comments, because what I really posted was a question actually. So I don't have all the answers. But before we jump into like the discussion and details about layer 2 control protocol tunneling, and it was related to Ethernet private line, so EPL, my question. So some background info. So there are 2 types of layer 2 control protocol, which has special forwarding rules in carrier Ethernet networks, or even in like IEEE networks. And it is bridged protocols, for example, link OEM and link aggregation control protocol. And the other type, the other group of protocols is multiple registration protocols. GVRP is one example, for example, that can auto-config like VLAN information. So that's 2 different groups. And MEF has specified how these special protocols should be handled, and it's done in MEF 6.1.1 and MEF 45. So those documents are kind of describing how these special protocols should be handled. And to be precise, there are actually 2 options specified. So for EPL, for example, there are option 1. There is option 1 and option 2. And option 2, the option 2 way of handling it is more transparent than option 1. So basically, these protocol in option 2, they should be tunneled from one end to the other, while option 1 actually specifies that some of these protocols should be discarded and they shouldn't be forwarded across the link. So this is quite good. I mean, it simplifies interoperability. These are protocols that can be used by customers, can be used by service providers and operators. So just to define how should these be handled. And you know what to expect, and you know what to assume that will work also. Now, the question I raised was whether option 1 or option 2 is the most common, and what is actually used out there most frequently. And the reason for this question is I mean, we are a provider of a software-based and agile on-demand service assurance tool. It's a solution called Netrounds, and one of our customer groups in north part of Europe, it's actually about 150 network operators that are aligning and standardizing amongst all of these 150 operators. They are standardizing how basically there's Ethernet service offerings to make it easier for buyers to buy their services. So they used our product to automate this service turn up and troubleshooting and so on. So, and since they are trying to align, of course they are looking to MEF, because MEF is the standardization organ to look at for carrier Ethernet services. They also specify attributes related to handling of control protocol, layer 2 control protocol. So the question is, or the question was that we tried to kind of get some input on, what should they specify as a default? Should it be option 1 or option 2? And of course, there might be like certain agreements between the buyer and the seller of a Ethernet service, so you might deviate from option 1 and option 2. But if they just put out, this is how we handle it as default, what should it be? So to make it a bit more concrete, I can share my screen here. Because what I detected also when I started looking at this is that it's not really obvious, it's not really standardized amongst like international carriers how to handle it either. So if I go I have written some of this on our website, so I actually created an article to summarize some of these things and how it should be handled, and here is a table. So pretty much if you have layer 2 control protocol action for EPL option 1, you follow this column, and if it's option 2, you follow this column. So for the different types, ether types that you have, you can see that there are typically different ways of handling it. And I would like to make an example of L2CP and link OEM in this case. So as you can see, for option 1, you have either you should peer or you should discard. So you shouldn't actually forward the frame all the way. Either you should peer and take part in this control signaling, or you should discard it. While in the option 2, you should actually tunnel it. And if we look at some examples that are yeah, you can find on the internet. So for example, Comcast has one example here. They have a really good specification for their EPL service. And let me see, maybe this is too small to, I will make it a bit bigger. So as you can see, for L2CP and Link OAM, they have peer or discard, which is, if I go back, is what is an option 1, the option 1 alternative. And actually, it's peer or discard for all of the other protocols as well for option 1. But if I go and look at the other type of protocol, for example, ELMI, etc., you have tunnel. So it's actually following, for these two protocols types, it follows the option 1, and for the other protocol types, it follows option 2. So it's not like consistent. And another example is Vodafone wholesale, and they actually handle it exactly the same way. So L2CP, LAMP, and Link OAM, it's either tunnel or peer in this case, and you tunnel all the other protocols. So coming back to like having looked at these different two real world examples and make it a bit more concrete here also to summarize it. I mean, it's really good to specify because these are protocols that are being used. So maybe I can go back and I will quit the sharing here. So these are protocols that are actually being used. They make a benefit in the network, and it's good to specify for interoperability how to handle these control protocols, and it's done in MEF. But it seems like in the real world, it's not really used either option 1 or option 2. It's actually maybe a mix between them. And in the discussion in the group, there was also some people that thought that okay, option 1 is what should be used, and there were arguments towards option 2 as well. And one of the maybe conclusions is that is not so clear in MEF is if you provide like off-net links that I am an operator only providing one part of an end-to-end, so I'm not the service provider, then maybe option 2 is a better option actually, that tunnel everything, and then it's up to the service provider to select either to use option 1 or option 2. So yeah, maybe this is of course a detail in everything, but it's quite I think many feel like a complex area, this layer 2 control protocol handling, and it's important for interoperability that you know how to handle it. So I think the discussion is interesting, even if it's a small detail in the MEF specifications.
So Marcus, just picking up on that, they were actually, I was looking through the thread, there were a couple of interesting thoughts that came up, and we may not have the answers to them. But one of them, which I thought was pretty fascinating, is that if these operators are using a mix of option 1 and option 2, then somebody made the observation, I think it was Larry or Ishkan, Larry I believe, that how do you get MEF certified? Because for MEF certification, you probably have to confirm to one of the specs, and you have to declare whether you support option 1 or option 2. And if you support a mix, then it's interesting, how would you get MEF certified? I think that's kind of an open question,
yes.
which is not clear to me anyways.
No, not to me either.
And then the other issue, which I think is relevant from maybe the kind of work that Netrounds does, is how do you debug things? If you use a mix of options, in your opinion, does it make the okay? One is of course the specification becomes a little bit more complex. Everybody has to see how much option 1, how much option 2, and are they using it in exactly the same way, especially in the context of the Ethernet networks in Sweden trying to talk to one another that you wrote about. But the other issue is that if you mix options, does it make debugging any more difficult? Do you think from a debugging perspective, things can get more complex?
Sure. And I think that the kind of motivation to actually test and make sure that it works the way that you expect is even more important in this case. So of course, if everything would be perfectly configured end-to-end, everyone is doing it the way they say they do it, and everyone is following specifications, maybe in a perfect world you wouldn't need to actually test and verify, but that's not what's happening in the real world. I mean, first of all, configuration issues, and this is actually details that I mean, many. The most common way to turn up a circuit is actually to do a performance test. So you just run packets from end to end. But in terms of like really making sure it works, for the scenarios you think. It's so much more that you need to look at, and layer 2 control protocol is just one example. But what you can do, of course, if you make a turn-up test or if you troubleshoot the connection, you can very easily and automated make sure, or at least highlight the issues that you have. So it will be clear.
If we have a specification of how we want to handle L2CP, is it possible to somehow program that, as you said, program that into the testing stage so that it's kind of automated? You don't have to, once you do it, you don't have to think about it. Is that possible? I mean, I don't know, with Netrounds or anybody else, some of the other testing guys.
Sure, I can't answer for the other test solutions, of course, but with Netrounds, of course, you can specify that this is the way it should work, and then you can just push a button and run a test and see that it fulfills the requirements you have. And I mean, even if it's not standardized, let's assume that you're not following option 1 or option 2. You have a mix of them. As long as you know what to expect, you can always run a test to make sure that the mix is correct. So it actually,
exactly.
Yeah,
exactly. But you have to be. I mean, and even among the operator specifications that you showed, I mean, I think there are differences in how they mix option 1, option 2. Even that is, I mean, we haven't found the operators doing it in exactly the same way. I think between the 2 or 3 operators, CenturyLink, Comcast, and Vodafone, I think they use it in different ways, right?
Yeah.
Okay. So I think this is an open, sort of still an open question that we probably should take back to the group and get more inputs on from some of the operators who are either doing it or thinking about it and are trying to figure out which mix to use.
Sure. Because I'm in a learning phase here, so I'm just interested to understand how this actually should work in the real world and what is most common, and so please provide input to the discussion.
Okay, wonderful. So guys, just a reminder, if the people who are viewing, if you have any questions, please post it on that discussion link that corresponds to the post for announcing this CE Live, and we'll take it there. And then let me then turn it over to Khurram. Khurram has come back. He had some internet issues, but Khurram, when we left off, I was asking you to kind of walk us through some of the analysis that you recently published on SDN Central regarding the options that operators have technology-wise for SDN NFV. And then I think you did a very nice follow-up where you talked about the non-technology issues that are also sometimes very important. So why don't you walk us through that and give us some of your perspective and your analysis?
Yeah, sure. Thanks, Vishal, for the opportunity to talk here. Actually, the motivation behind me writing that article was that we have seen a lot of movement in the industry in the past couple of years. The technology has moved perhaps too quickly, and the array of solutions out there are so complex, and sometimes it can be very difficult, especially coming from a service provider background, to actually understand what are the real technology options. Like in the case of SDN, the very basic thing, which is the definition of what is an SDN, is still in question. So different people tend to define it differently, according to their own solution, according to their own strengths, and so on. So, and similar is the case with NFV. Now, NFV is a little bit more straightforward, but it has its own set of complexities and issues that have to be addressed before it can be deployed in real commercial networks. So I thought it to be appropriate that we should try and understand the market landscape, what are the technology options, and what are their pros and cons, and what could be the relevant use cases for telecom operators. So my articles, actually both of them, are from telecom service provider point of view, because I have been engaged with, I have been working with a telecom service provider for several years now, and I have been engaged on SDN and NFV initiatives for some time. So coming to the analysis, my first article, perhaps I should share the screen here. Let me see if I can do that. Right. I hope you would be able to see that.
Yeah, we are seeing that.
All right. So this is talking about the technology considerations for SDN and NFV. So first of all, there are multiple flavors of SDN. And it is very important to acknowledge that there are differences, there are pros and cons in each of the flavors, and then to make a choice by the operators that for which use case, what kind of SDN solution they want to go towards. The three major solutions are OpenFlow based, which was the first flavor of SDN that came out of Stanford like in 2008, and it was the first deployment that Google did in their data center in 2011, which was the tipping point or which started the revolution of SDN.
Sure.
But and it has several advantages because it completely separates the control plane and forwarding plane, and it puts all the intelligence in a centralized controller. So the traffic flow becomes extremely deterministic. However, it has its own disadvantages, like each node in the network has to support OpenFlow. So we are really talking about replacing the entire networks which have been built over a period of decades. And also the white label switches that are touted to provide the low cost entry point for forwarding devices are very exciting, but they are not yet capable of carrying scales of traffic, hundreds of gigabit or even terabits of traffic that the core routing equipment in a service provider is doing today. So this is a direction which is definitely to keep an eye on, and the current deployments based on OpenFlow have been limited to data center environment. So we have not really seen a successful OpenFlow deployment in the WAN. However, there have been some attempts. For example, NTT has done some work, and AT&T announced in their domain.2 that they are experimenting with how to bring it into the WAN, but they are also experimenting with other flavors. The second one was control plane extensions, where what vendors did was that they said that we will enhance the capability of existing networking gear and then extend the control plane to a centralized controller. This way, they said that we can automate the provisioning of services over existing network without without the need to change the hardware, and at the same time we can have a lot of benefits that are related to cloud and virtualization. For example, we can have the same level of flexibility, agility, efficiency, resource sharing, and so on. However, the disadvantage is that this approach is going to add another layer of complexity because there is going to be a dual control plane running both in the device as well as in the controller. And it will not result in any capex reduction. Actually, it might result in increased capex for the operators. So it's not very clear that it's a very lucrative approach in terms of the business case when we come to the real world deployments. However, it does provide a very fast entry point. Sorry, Vishal, are you saying something?
Yeah, one quick point. This control plane extension approach, I mean, here it's been proposed for the WAN, and you know, that is maybe more difficult to implement. But if we think about it, the Facebook approach that we just started with today, I mean, they're kind of doing that, right? Because in that 6-pack switch, they're putting a little control plane on the switch, and then it's managed by a centralized controller. The only issue is that all of that is happening, at least for Facebook, inside the context of a data center again. So, you know, they don't have the complexity of a control plane operating across a WAN. And so they're able to do this approach, but they're not doing it, you know, in their backbone, for example.
Yeah, I understand. Actually, in the WAN or in the service provider network, the ballgame is quite different because we have a lot of complexities, a lot of technologies are deployed there, and the use cases are very complex. We need to have, and there are a lot of uncertainties in the network that needs to be addressed. That's why this control plane extension actually might provide easy route to bring in some programmability and some software-defined capability in the network. And there are a lot of vendors, including the major ones, who are actually supporting this approach. The major reason is that it does not really take away their hardware. For example, the likes of Cisco and Juniper are fully supporting this because it still utilizes their hardware gear, which is the bread and butter for those companies. And we still have to wait and see that how this approach pans out. However, there are a lot of commercial deployments which are being planned or which are being announced by different operators in the world using this.
It seems to make sense from an operator's perspective, right? But at least you don't have to swap out all the hardware. You can kind of maybe do things in an incremental way. Unlike the open flow approach, where you need everything to be open flow compatible for you to really make it work. Here, you can maybe have a mix and match of different gear and gradually bring in more sophisticated equipment without having to swap everything out.
No, absolutely, absolutely. I totally agree with you on that point. However, the only concern that I want to highlight is that this approach does not really fulfill the promise that SDN brought in, which was reduction of cost. Because if we go back, the basic problem why operators said that okay, we need more software-defined capability and we need an SDN was that the current business model is not sustainable enough. The capacity requirement on the backbone of the network is growing exponentially with the explosion of data, and the revenues are not increasing with the same pace. So operators simply cannot keep on investing on expensive, complex hardware routing platforms. And they actually need to find a way to reduce their cost of providing this exponential bandwidth. I mean, if I look at my example, I mean, the internet capacity that we are providing to our customers keeps on doubling every year, and it is increasing. So this is something that, I mean, there is no way that after 3 to 5 years, we can still we would still be able to expand on the same networking gear. It simply does not make sense. So yes, in the medium term, it is a very nice approach because it does provide a migration path, which is seen to be a big challenge for SDN. However, we need to be aware that this is not the pure definition of SDN. That's what I wanted to highlight. Then there is also a third approach, which is overlay abstraction on top of existing network using different kinds of tunneling protocols. VXLAN was the first one, and then there's the NVGRE and so on. VMware, or actually Nicira, was the one who was quite successful by providing overlay-based SDN solutions based on VXLAN. And there are other vendors who are following this suite as well. The biggest advantage of this solution is that you do not really have to touch anything in the underlying infrastructure. So the infrastructure is completely unaware of the abstraction, which is like the tunneling, which is running layer 2 protocols on top of layer 4. So it is very similar to the virtualization concept of compute and storage resources, where the underlying physical infrastructure is unaware of the virtualized environment running on top of it. However, the disadvantage is that it does add a lot of overhead, and it is not scalable in a WAN environment. So
this has been primarily within the data center, or in the, where have we seen overlay abstractions? Primarily in the DC?
Exactly. So actually, early deployments by different operators was within a data center was based on overlay abstraction, because it has the fastest time to market. It's very easy to deploy. Only the end nodes need to support the abstraction capability, and the underlying infrastructure, complete data plane fabric, all the routers and switches and so on, do not even need to be touched or do not even need to be reconfigured. So it's a very fast environment in that perspective. However, it's not really scalable in the WAN. Now, Here, in this analysis, I tried to give example of all these three approaches, that what are the solutions out there, what are pros and cons, what are the use cases. And I also want to highlight here that there is an open source initiative called Open Daylight, which is trying to bring together multiple approaches in one. So actually, Open Daylight provides an abstraction between the underlying infrastructure, which could be a hardware or a virtualized switches, Open-V switches, and the controller, and between northbound interfaces, anything which is riding on the north side, which is the abstraction or orchestration or any applications riding on top of the platforms. So for the southbound interfaces, they have adopted the use of multiple approaches. They are using OpenFlow, as well as they are also using various control plane extensions like Yang, NetConf, BGP, LSP, and so on. So this looks most promising among different alternatives, but we have to say that it's still in the second release and it's not mature enough, but it is the one solution to keep an eye on. Now, similarly, when we talk about NFV, we see that there are ETSI ISG NFV work group has done a very good job in creating a reference architecture and defining the use cases for NFV. Actually, those use cases cover pretty much every area of a telecom provider network, including fixed and mobile core, your content distribution, your access network, whether it's fixed or mobile, your FTTX, your base stations, even your customer, the equipment at home or enterprise, which is the CPE equipment. So all of them are going to run as a virtual functions. However, the problems are like, do we need to extend the existing cloud computing platforms or build NFV-specific clouds? Because the capability requirements, the reliability, resilience, quality of service control are different for both of them. Also,
exactly. That's a very good point. Also, the way you might want to service chain VNFs, right? That's the big deal with NFV. You want to create service chains of VNFs, and is that easily feasible in existing cloud platforms, or whether we need specialized clouds? I think that's an open question pretty much at this point.
Absolutely, I totally agree. Absolutely, and I think SDN can come handy in doing the service chaining, because what you need is a high-level orchestration platform plus an SDN controller, both of them talking to each other, so that SDN configures the network part of the chain, and orchestration configures all the different applications, and then they can talk to each other.
Yeah.
So this is, I mean, in theory, this is how it should work, but in real world, it's still some time off. So it will take some time for solutions to come out. Then the next is that a lot of vendors are focusing on building NFV based on individual use cases. If we try and do
that is the big problem in the market, right? I mean, everybody talks about their version of NFV, but it's only one or two use cases, and that are covered by that.
So we can very easily end up in a situation where we have multiple NFV silos in the network. One NFV for EPC, one NFV for IMS, one NFV for SDN, and they don't talk to each other.
Exactly.
So at the end of the day, we wouldn't have gained anything out of this whole NFV. I mean, the whole point of moving towards a virtualized infrastructure was to get away from vendor lock-ins, get away from costly hardware which the vendors bring, come to a standardized COTS-based x86 platform, which is much more cost-effective compared to the hardware-specific or custom hardware platforms, and at the same time have the ability to bring in best-of-breed solutions based on software.
Exactly.
So the current approach, which a lot of major vendors are adopting, is actually going to negate this phenomenon, because they are focusing on building their own ecosystem from end-to-end perspective. Different vendors are doing like integrations and their own POCs with their preferred partners and so on. So the choices at the end are going to be very limited for the operators. So this is something where ETSI has actually stepped up, and they have said that in their second phase of standardization, which has started this year, they are going to focus more on the interoperability and also defining the interfaces between different functions of the architecture, like between the VNFs and orchestration, and between VNF manager and the infrastructure underlying. So these interfaces have to be standardized. That is extremely important.
But so far, we are not making a whole lot of progress in trying in that standardization, right? I mean, that's that to the best of my understanding. Are there bodies that are working on that? I mean, the usual culprits, or that you're aware of?
The problem is that traditional standardization bodies like ITU, for example, have been notoriously slow in working on new standards.
Sure.
And IETF is another story. IETF is working on a lot of things related to SDN and also service chaining in NFV. But NFV itself is a new area, so there is no specialized standardization body. ETSI has taken this role because, I mean, if you remember a couple of years ago, 13 of the largest operators combined together and they said that we need to do something, so they initiated this work group. So they have completed their first phase of, let's say, of deliverables, which is the architecture, use cases, and also a high-level overview of how the standard should look like. But it's a descriptive standard, not a prescriptive one. So they are just providing how.
Problem. I mean, I mean, Tom Knoll and several other sort of industry experts have been writing about sort of the difficulty of that approach. It tells a lot of things, but then the devil is, as everyone says, the devil is in the details, and sometimes those details aren't complete. Specifically, things like interoperability and how does interfaces talk to one another and so forth.
Exactly. Actually, recently there have been another development. There is another entity called OPNF.
Yes.
Which is an open source community where multiple vendors have come together and said that, okay, we should bring up interoperable NFV solutions from different layers, which is, I think, a step in the right direction. I mean, it might take some time, but the approach that OPNF is taking is quite open and quite similar to what Open Daylight is doing, for example, in SDN.
Sure.
So we might have light at the end of the tunnel in that perspective.
Sure. So, okay. Right.
So just a couple of other points before I wrap up on this particular article. Here, a lot of operators, a lot of vendors are just migrating their functions from whatever way they deployed in the physical infrastructure to a virtual environment. The point here is that it might not be enough, or it might not be efficient, because those functions were developed to run in a dedicated hardware environment with each function very clearly defined. They were not designed to work in a virtualized environment. So graceful migration is really, there needs to be some architectural overhaul for applications to work efficiently in a cloud environment.
Exactly. And then just a quick point, I mean, that goes back to the approach that Facebook takes. They decided to disaggregate everything, but then they were building things up from the ground up in a modular manner, taking their specific requirements into account. So they didn't just take the regular functions and just put them in the cloud. They kind of built the pod architecture, they built their own data center architecture from scratch. And a similar philosophy has to be taken even when vendors start to put their things in the cloud. It's not just, okay, you put it on a bunch of servers and you're done.
Yes, I totally agree. Perhaps the irony is that, I mean, now the technology is driven by these Facebook and Googles of the world, and really the telecom service providers as well as vendors have fallen a little bit behind in terms of their risk-taking ability or their dareness, if I may say, or they have become a bit more stagnant. So a lot of innovation is being driven by Googles and Facebooks of the world currently. So I totally agree. There needs to be a change of approach. They need to be more takers they need to change the architecture from bottom up. Actually, I'm aware that very recently 3GPP has started a work group to optimize their 3GPP architecture. You might be aware that 3GPP is the main standardization body behind all
Wireless.
defining the interfaces and protocols of how the core network works, both packet core and circuit core networks,
Sure.
including EPC, IMS, and all that platforms. Now, they have decided that, okay, we developed those frameworks or those architectures based on hardware-based nodes. Now, that's not going to be the case anymore. So they are going to redefine their base architecture, and then I think that will be very helpful for our vendors as well to come up with solutions that are optimized for a virtualized environment rather than just a direct migration.
Absolutely, because one of the biggest challenges in doing the virtual EPC today is that everybody has to think about their own approach to doing it.
Actually, yeah. I mean, if everybody has to do their own approach, that's also a risky business, because because then we will again end up in silos. That one vendor has taken certain functions and then customized the operation of certain functions in a way that they have come up with a complete product. But what happens when you try to plug in a different function on top of the same platform and try that function to talk to various components in that function? I mean, we have examples of such solutions that people have been trying something, but it's not a big success so far. So you have to stick to standards for it to be a scalable approach.
Sure, sure. So can you also maybe quickly cover some of the non-technology aspects, maybe not in this much detail, but in a couple of minutes, without showing the article? Can you just talk through that and talk to us about some of the non-technology, 2 or 3 of the biggest non-technology barriers that are really also very important?
Yeah, sure, absolutely. I mean, the main reason that why I wrote that article, because operators and generally the feeling in the industry is that they feel that technology is not mature enough, so we have to wait for technology maturity and then there will be adoption of SDN and NFV. But that's not the whole picture. Actually, the scale of disruption that SDN and NFV bring in a service provider network is so huge that they have to transform their own internal operations as well. They have to transform the way that they work, and it has to cover everything, starting right from their strategy, how they structure themselves, what are the capabilities, skill set that they have. Today's skill set is not going to be sufficient in a cloud-based environment. Their processes, their business model, and also the way they manage and how they offer their services to end customers. All of this have to be rethink and revamped to suit a cloud environment. So a lot of work which needs to be done in terms of internal transformation of organizations if they want to really benefit from SDN and NFV. I mean, technology alone is not going to be enough in this case.
Absolutely. In fact, we had some operators. There was something called SDX, the SDX summit that was here a couple of months back. We had number of operators, PACnet, AT&T, PCCW, etc., who are doing things in the SDN and NFV space, and among other things, this was by far one of the big sort of considerations. How do they change their thinking? And we've seen that, maybe again when we had the IP network deployment in the late 90s, early 2000s, when again operators had to change the thinking, that the IP network thinking had to come in and move away from TDM, ATM network thinking, and required multiple groups. Now, of course, the challenge is you can't have multiple groups. You want one integrated group that looks at wireline, wireless, cloud, SDN, NFV, and I think it's much more challenging than it was maybe even 15 years back.
Yeah, absolutely, absolutely. You said it perfectly. Totally agree.
So, Marcus, I mean, what are you seeing in sort of Sweden and Europe? Are you seeing operators struggling with some of these issues? Are there a few outliers who are ahead of the pack? I know Sweden traditionally has had some sort of advanced operators that have done nice things. So what is the situation right now for you all?
I guess you're referring to SDN and NFV now, right?
Yes,
It's a bit,
yes. In terms of
yeah.
that kind of adoption and embracing that philosophy.
Yes, from my perspective, I think there are a few big operators, European operators, that are part of the driving force. It's really the biggest ones. I would assume like Deutsche Telekom and maybe Swisscom and some other very big operators. In the northern part of Sweden, I don't feel there's the same drive. So I think from the US and a couple of the largest European operators are kind of driving this. I could add like an interesting aspect because we are also a DNF provider basically. So maybe share some thoughts from that perspective. And because you mentioned here earlier that many of the like appliances that are going, or the DNFs that are going to be using NFV architecture, they are born in the hardware industry and they need to kind of struggle to get this working in a virtualized world. And we are on the other side born in the software world. So for us, it's quite interesting to see that the measurement device that we have, the software, and actually we can see that this software can easily run in several different vendors' kind of NFV platforms, like Cloud Metro platforms and things like this. So it's typically based on OpenStack today, and it's kind of the same in at least for the ones that we have talked to, like Lucent and some other big ones. They are kind of easy to take our measurement device and deploy it into these NFV areas. Of course, this is just one. I mean, one of the interesting DNFs. Imagine that you don't have to send a technician out to do a turn up with a hardware-based testing. Instead, you can, as part of the orchestration, you turn up the service. As part of that, you push out the VNF that can also verify that everything works. Kind of close the loop, so you can see that everything works by software, maybe done in seconds or minutes instead of several weeks. It's really exciting, and for us, kind of one of the innovative companies in this service assurance industry, because we are a new player and kind of if we were going into the hardware-based test instrument industry, it would be kind of a big mountain to climb. It's a lot of cost, and you need to kind of build up a reseller organization. But with DNF, it actually truly makes innovation possible, and small innovative companies can actually come in there and provide really great products. So it's with a great optimism we see this happen.
Wonderful, wonderful. No, I agree with that. It definitely opens up the field for a number of different smaller companies which have now cloud-based solutions to offer. So let me quickly just tell the viewers and those who might be viewing it later on that there's a mind map of the entire discussions, and I'm going to be closing in about a couple of minutes, but let me just show people that mind map so they visually know what they're looking for, and we always provide a link to that at the bottom of the video and the bottom of the Google Hangout piece. So one sec here. Let me just share that with everyone. So guys, this is the mind map that you will be seeing. It will be a clickable mind map. What I wanted to show you is that there's a lot of nice information hidden here in terms of the references for the specific things we talked about. So these are the links to the articles. This is some link to the data center stuff. I have some nice things linked in terms of a lot of background information on Facebook's strategy. And you might want to look at the Open Compute Summit, those that are in the Bay Area. That's coming up in about a month, just a couple of weeks. And then we have a lot of references linked for Marcus's EPL discussions, specifically the 3 different operators specifications he talked about, and the Ethernet specs from the MEF that are good to look at. And then there are some links to some other videos that we created on monitoring uptime and the radio cloud discussions that I did with you. and there are references for that. So just for you to be aware of that. Obviously, we don't have time to discuss everything, but we discuss some of the key highlights of, I think, the most important discussions, and that are also most important from a technology and trend perspective. So Marcus and Khurram, first of all, I want to give you my sincere thanks for taking the valuable time to come and talk about the problems and share your sort of expert insights. I think that's extremely valuable, and we hope to continue the discussion back on the group with regard to people now having opinions or questions. Marcus, in your case, obviously it's an open problem, so I think the discussion is going to continue, in that form or somewhere else. And I thank you both for coming. And as I always say, I always end with my standard tagline, which is, may the bits in your bytes and the bytes in your packets be profitable. And we'll see you next time.
Bye-bye.
Thank you very much. Bye.